All right, welcome to BS&BEER Canada, everyone. My name is Aaron Jones. I'm a carpenter and a builder, typically over here somewhere on the East Coast, but today I'm over here on the West Coast in Kelowna area. And I am drinking a local cider by Truck 59. It is a bourbon barreled blackberry cider, pretty tasty, I must admit. And I'm not going to introduce our guest quite yet, even though he probably needs no introduction. But I'm going to flip it over to our foreign correspondent, the one and only Mr. Mark Willie.
I'm not on the east or the west coast of Canada. I'm quite south of the Nickel. Uh, I'm all the way down at an off-grid property in San Antonio, where we're in the final fit-out stages. We can't wait to do another blower door to make sure our penetrations have been covered. And I'm looking very forward to just a few days away, actually, a week ago yesterday, to being in Vancouver myself for the awesome symposium. And I look forward to hearing from Robert tonight. It's always a favorite of mine, and nice to see all those brilliant faces out there.
Thank you, Mark.
Hey, I'll jump in. I'm Connor Malloy. I'm an educator in Toronto. We teach at George Brown College. So really big push for us on trade schools and trade school education. We teach carpentry, and part of carpentry is also high performance building and detailing. So having guests like Robbie here tonight and learning from, again, product representatives and experts is really key for us and helps us. So thanks for joining us, everybody. I live in Toronto, which is closer towards the center. Mark, we're west of the Toonie, east of the Loonie, and north of the Dime is where we're based. I haven't left my neighborhood in a long time, so I'm very jealous of those that are traveling. So let me flip it over to my colleague, Justin.
Hey everyone, Justin Ott with Element Construction, Lumsden, Saskatchewan. We're a custom home and renovation company focusing on high performance builds and really showcasing the benefit of high performance housing in Saskatchewan and where Passive House started. So yeah, thank you.
Without further ado, I'd like to introduce a fellow building science enthusiast, blower door nut, and someone I like to call a friend, Robert.
Thanks, Aaron. Robert Rozon, Regional Sales Manager for Uber. I've been with the company for over 10 years now. Let's say having fun traveling the country to help builders and let's say dealers and distributors about learning about the products and new techniques to put in their, let's say, for architects in their drawings, different ways of thinking. Tonight we're going to talk, yes, about Zip, but I'd like to talk about the case study that was done, and I'm not taking any credit for it, but the Builder Association in Quebec and Laval University. So it's going to be fun. Let's say they called it the perfect wall. I know nothing's perfect, but let's say it's kind of fun to discuss and understand how, let's say, it could change the dew point position and stuff in the wall assembly. So it's going to be something that we're going to discuss a little bit later. So yeah. So thank you. And I'm drinking Red Ale from a local brewery in about 35 minutes from my place on the South Shore of Montreal. So I've been with the company, and just a quick introduction about the Uber Engineer Wood. They've been in business for over 140 years in the wood industry since the 1940s. We also have Uber Resource Corporation managing the forests in the states and stuff. I've been in this business for 28 years, but the last 20, a lot of it was involved in the building enclosure, building envelope. So. I like traveling for sure. Let's say traveling in Canada is fun, but I'm also traveling overseas, everywhere. Let's say a couple of weeks ago was in Switzerland, so it was a nice trip with my wife. So we had a lot of fun. Let's say the family, one thing that they decided back in the days is to move out of the commodity business. So I was lucky enough to be probably one of the first in Canada to sell Advantech in retail in '97. So when I started my career in this business, and then in the mid 2000, let's say they created Zip System building enclosure product, integrated WRB, weather barrier, air barrier. And that's something that is also nice to discuss because let's say, pretty sure in Canada, when we look at the drawings and we look how builders are doing their stuff, probably 90% of the air barrier is still done on the inside instead of on the outside. So, but let's say I'm hoping that in less than 2 years or in 2 years, let's say blower door tests will be mandatory like they are in BC right now. And let's say it's something that will just make our building better, our technique better. And so we'll have to look at those things. I know, let's say the group over here, let's say I'm pretty sure everybody's already dealt with, let's say, a blower door test, but that's really the most amazing thing that you could do for your building. Let's say they're not expensive. Homeowner will be saving energy down the line. So we all know that energy will just increase in price. So um, let's say the WRB on Zip, let's say makes it so easy to put together. Doesn't really change anything. The panel are going on the wall just like regular sheeting. Then you tape the seams. Let's say we have all the accessories. It's more like a system. Let's say some people, even some builders are saying, let's say I'm using Schutler when I'm doing ceramic in the shower, but I'm using Zip when I'm doing my building enclosure for walls and roof. So it's kind of a similar situation. But a lot of details are also coming from Advantech, let's say being the strongest and stiffest subfloor panel in the market. But we get that also when we deal with the Zip roof, let's say. There's a lot of guys, let's say when they think about Zip, they think about the wall, but there's more and more people now looking at the roof because let's say it's fun when the framers are done. They did put the tape on the roof. It's rough drying. Let's say all the trades will benefit from it. They could come the next day, not wait for a roofer, and it's just going to speed up the process for your building. And everybody will appreciate a really dry environment to work in. Over the years, let's say we did work with the Builder Association in Quebec. It was kind of kept secret at the beginning, so we were involved, but not that much at the beginning. But at the end, they made a first case study. And the cool part, let's say, when you're talking about wall assembly, a lot of people think, high performance building, more expensive, and all this stuff. And the cool part about that project is they did it, let's say, kind of in the center of Quebec, and they did it for first time buyer user. So they went with they did build two building, one with a code, which in Quebec is pretty much R20 plus 4 on the exterior as a CI, continuous insulation. And they did the perfect wall. And the perfect wall, let's say, I'll bring that. Let's say we all know perfect wall from Joe Stieberek. Had the chance to take a couple of drinks last year in Toronto at the symposium with Joe. And he told me, and I'll say it's coming from Denmark and it's from the 70s, let's say. Um, so when we look at the history of our walls, let's say if we go back in the 80s, we were about 70s, 60s, 80s, 70s. We were building with 2x4 with R12, 13 in the cavity. That was pretty much it. In the 80s, early 80s, let's say they wanted to add outboard insulation to the process. And what happened then is, let's say, the gas crisis. So any kind of insulation, plastic insulation, the price went up. So instead of moving 2x4 just with outboard insulation, they went with 2x6, adding more R value into the 2x6. Now we're kind of doing a mix of both 2x6 plus outboard insulation or double stud walls and all the system. So that's kind of the way that we're seeing things. Let's say with the perfect wall, we did that one with a 2x4 construction. I'm not saying that most of people will go back to 2x4 because 2x4 will have its limit. When you think now, let's say a lot of our buildings are 9 foot, 10 foot ceilings. So let's say 2x4 is a little bit, it would be a little bit more difficult to manage with that. But let's say it could be done with 2x6. And when you look at the component, all the list of products that we've used, we had furring strip on the exterior to add the siding. So let's say water management. Let's say we always work with the 4Ds: deflection, drainage, drying, and durability. But let's say deflection, you start from the roof and go on and go on with all the details that you're going to be putting. And remember, flash, safe, cache. And let's say Aaron is always bringing that up, but yeah, it is through. So, and then when you look at it, we had 3 inches of outboard insulation. Let's say, uh, and by the way, I did right now. That is a case study that was done by the Builder Association and the Laval University. But I did 5 more with the perfect wall, and I did. There's 2 on the way also soon. And I was lucky enough to visit one that was in northern Quebec, and that morning it was minus 32 degrees. Uh, and during construction, and they were heating the building with a 1500-watt heater, which is not bad. So that was pretty cool. And the one that they did with the Builder Association, they did use a Rockwool comfort board on the exterior, which is perfect. You could use EPS, you could use wood fiber. We're probably going to see a little bit more wood fiber in the future. It makes sense. Then we did put the R12 behind. So the fun part about the R12, it gives you your air barrier, weather barrier, your structural sheathing. So it gives you the structural lateral strength that you need for your building, plus a continuous insulation too. So which is kind of cool. So a one-step process in this. We're going to get back to it a little bit later. Also, in the prefab process, could it be done prefab? Yes, probably not all of it, but most of it. Uh, the zip tape, stretch tape. There was a little bit of liquid flash to involve. The 2x4 without any insulation. Let's say a lot of people are talking about the dew point, but we kind of forget that like the cavity insulation could be creating more dew point if you're adding more because it's creating more restriction. So we're going to get there during the process. And in Quebec, let's say normally they're putting furring strip on the before putting drywall, but because there's nothing in the cavity, let's say they're putting furring strip to put the drywall, but to leave a little bit more space for electric and all the stuff, all the component coming in. To put a furring strip on the outside, we did use structural screws in this case. It was JRK, so but it could be U2 fasteners and stuff. So you typically have the full detail. So you get a RSI of a 4.74, 26, almost 27 total. Um, so, and that's effective R value. So, which is kind of cool. So it means that it's pretty close to our R32 wall assembly. But there's no cavity insulation. And
Just so
when,
you know, Robert, your
yeah,
slides aren't showing.
are you seeing them now?
No. Um,
No.
I thought
So,
I would just jump in and let you know that
yeah, that's a good point.
To be fair, you describe it so well, I could picture everything you were saying.
Thanks,
well,
Mark.
that's why I didn't stop him sooner. And then I was like, hey, not everybody watching may quite agree with that. So,
Do you
anyways,
see it? Do you see it now? It's on?
you're on.
Good. Okay, perfect. So sorry. So yeah. So I'll just go back there just to show you. So the exterior insulation that was added over the R12, the 2x4 construction, and drywall with the frame strip. So over here you get it. So we get the full R value. So R27 effective. So one thing that let's say we don't like in Quebec, we're still working with nominal R value. I think that has to change. There's not a lot of provinces that are working that way, but it's something that we will have to bring. So that was the wall assembly on one side, and the other one had a R20 plus 4 on the other building. And let's say the window details were pretty much done the same ways that our instruction are done. But in Quebec, let's say instead of using flange windows, they're using brick mold windows. So there's a little bit more work when you do that because you have to cover the rough opening before. But let's say the flashing details are exactly the same, so it doesn't really change much on those things. Let's say the key in design and installation was pretty simple. Let's say use a roller to apply pressure on the tape, but it's for any kind of tape. All tape are pressure sensitive, so it's important to always apply pressure. Let's say if you don't have anything, don't tell me that you don't. Let's say I don't have a roller, I cannot do it. Let's say a credit card will do a good job. A plastic squeegee will do a good job. Let's say there's your speed square will do a good job. So that's really important. The funny part about that project is it was the first time for those guys to do a blower door test. So they did it on the typical assembly and the perfect wall assembly. So and we did let them make some mistake. So I'll show you the result a little bit later, but there's a funny story about that one. The nailer, let's say using R12, for sure you're gonna have to use 4-inch nails, 0.131. There's not a lot of nailer that will do that, but there is some that are doing from 2-inch to 4-inch. Okay. A lot of people are scared to deal with let's say the big 4-inch to 6.5-inch. They're heavy. It's like, let's say, working with a dumbbell all day of 30 pounds makes no sense. So there is some nailer that will do a good job with that. So there's a nailing pattern also for lateral strength on zip-R, which is a little bit different than regular sheeting. So on the edge of the panel, you're at 3 inches on center, and in the field of the panel, it's 12 inches on center. That part doesn't really change. The cool part is, let's say, the condensation risk in the wall assembly. And we were talking a little bit about the dew point earlier. Let's say, like I said, because there's no insulation in the cavity, it will let the energy to transfer up to the interior of the sheeting. So if I had a piece of OSB, plywood, or anything, let's say condensation will normally happen on the interior face of the exterior sheeting. Okay. That's typically how it will happen. In this case, with the zip-R, we had the foam with the fiberglass coating on the inside. So this is where the condensation would happen. On the other end, on the other building, they had R4 on the exterior with an EPS foam. So it was on the interior face of the EPS foam. So that's normally how, let's say, dew point, let's say the condensation will happen, and it will always be on that surface. But because you put a lot of insulation, you're increasing that temperature, that inside sheeting temperature. So less chance of having condensation, but having an open cavity lets the energy transfer to get to the interior of the sheeting. So second thing is, let's say we were doing blower door tests, and most of you are doing blower door tests. So let's say it's so important. It's something that we do. Let's say we were having a discussion with Jeremiah from Summer Brother a couple weeks ago. Let's say I agree with him. Mid construction blower door test should be also mandatory, not only the one at the end. So this way, it's a lot easier to manage your leaks and stuff because let's say if you find something above a window, you're not going to find it at the electrical outlet on the inside or anywhere else. It's going to be right in front of you. So that's a little bit easier to work in. But let's say that will probably put an extra cost for the blower door test of what, $300 to $400 maybe. So it's not that bad. The continuous insulation on the outside. So continuous insulation will prevent condensation from happening in the cavity. So that's something that you deal with. Let's say working with a system, let's say you're relying on, let's say one product, which is kind of cool. So you know that the products are made to go together. So it's something that we do. So, and it's nice because I know, Aaron, you're doing this on one of your projects. So on the left side, there was some sensors on the walls, and they were managed by the university. And the cool part is, even the family, since they got in, they told the university, if you want to still keep the data coming, let's say it's all good. You do your stuff, and we're good with that. So that's pretty cool. On the right side, you see more conventional assembly with cavity insulation, vapor retarder, the flooring strip to put the drywall, and there's some sensors all over the place. So just on the bottom, you see where the sensors were put. So it gives you a pretty good idea. of the result that we got. But let's say, like I said, I wanted to bring your attention. Yes.
Lumber and cut new ones.
Sorry, Alex.
Oh, I'm sorry. I thought I was muted.
No problem. That's good. So I wanted to show you where, let's say, the condensation would happen. So on the conventional wall assembly, so which is a 2x6 drywall on the inside, the Frank strip on the inside too, before the drywall, you add an EPS foam plus a wood fiber sheeting. So the condensation would happen on that surface normally. On the zip one, on the perfect wall, let's say you add a lot of outboard insulation plus a zip panel. So it would be on the interior face of the insulation with a 2x4 construction, but no cavity insulation. So over here, the straight line, the purple straight line would be the dew point. So around 4 degrees, okay? Interior temperature, around 19 degrees. Going down a little bit on the inside surface of the drywall, and that number is at minus 20 outside. Okay, just to let you know. So over here you get the temperature of the interior face of the sheeting, which is still 16 degrees, which is pretty high. So way above the dew point. If we move to the next one, let's say you see that the family is not eating at the same level, so 19 to maybe 21 degrees over here. The interior surface, so the dew point gets up a little bit more because of the cold temperature, the relative humidity and stuff. And you see here, the interior surface was at minus, 13, 14 degrees. So we're talking about almost 29 degrees difference between the two. It's a lot. So you see that the cavity insulation, what it does, it creates a little bit more restriction. So if you were doing a R12 plus outboard insulation, and with the same amount on the outside, the R12 would be better than the R20 with the same amount on the outside to manage the dew point. So it brings others' idea on how to manage the dew point also. So the interior surface over here, for sure, at minus 13 degrees, there was frost in there, for sure. So people that are doing remodeling, renovation in the winter, you're trying to pull the fiberglass insulation, it's stuck to the exterior sheeting. It's normal, okay? And let's say dew point will always move up and down, so that's something that we're going to see. So vapor barrier, we didn't put any because there was no need to do it, okay? Let's say could have been a smart vapor barrier, but in this case, with that kind of temperature, didn't really change anything. Let's say the air barrier we were working with, let's say our system was done. They had a result of 0.84 ACH. When they gave me the result, I was kind of disappointed, but they told me it was not leaking from the air barrier or anything. It was leaking from a patio door, which was a first-time buyer patio door, a plumbing vent, and also a window, plus the over the kitchen too. So it was not leaking from the air barrier. So they did perform a blower door test. It was the first time for the builder to do a blower door test, and they did it on the other one, and they did 1.3, which is pretty good when you think about it, because let's say net zero level will be at 1.5. So it's something that they've done. The flashing and waterproofing, let's say, when you look at our details, but let's say it's always important to look at the details, but we like to be involved at the beginning. Why? Because we want to manage those things. Let's say if we try to fix something at the end, it's always more complicated. Let us be involved. We'll look at your drawings. I had a couple of calls this week. People did send me the drawings. I made some adjustments, send them back, and they're going to make some adjustment to their wall assembly. Let's say air barrier needs to be continuous. So you're going to have some transition from the foundation up to the sheeting, and then at the top plate level to meet, let's say, the vapor retarder from the attic and stuff. So there's some details that you need to look at those things, and let's say, let us be involved. Let's say, and it's probably the same thing for other manufacturers, but let's say I like to be involved at an early stage. For sure, with that amount of outboard insulation, let's say if you want to put brick, let's say the foundation would be what, 14 inches. It would probably be very difficult. So I'm not sure if it would be the typical wall assembly for that application. But if you're putting, let's say, vinyl, fiber cement, engineered wood, uh, or even stucco, it could be some of them could be done. Composite siding. There's so many things that could be done with that. So it could be left exposed up to 6 months with zip, and then you put your siding, which is kind of a cool application. The shear strength, I'd say we did use zip art. If we were using regular sheeting, OSB plywood, that would be fine. Um, if we are using a combo panel, zip art is the only combo panel right now approved for lateral bracing in Canada. Okay, we know that because the CCMC had to create that test for us, so we know the details. And let's say the code is very permissive on structure right now. Let's say when you look at the residential code, if you're building with the section 9 of the code, you could build up to 3-story high relying on drywall. Does it make any sense for anybody here? Probably not. Okay. But we're seeing it, let's say, especially since we're seeing more outboard insulation. Some track builders decided, oh, we're going to offer the outboard insulation, but we're going to remove the structural sheeting because let's say we're going to rely on drywall or metal windbreaks. So it's not something that we're seeing. But the fun part is in the 2025 National Building Code, that part will be changed. So they're going to be still allowed to do relying on drywall, but only for a 1-story building, not 3-story. So that's going to be cool. But even with ZIPR, we're approved in section 4, which is the engineer section, and section 9 for residential too. So we were well covered with that. Winter construction, let's say with ZIP, we could go down to minus 18 degrees. Let's say I know Justin is dealing with some lower temperature than that, but minus 18 is it's a good one. If you're calling me below that, I might not see me on the job site in the morning, so I might wait for the sun to come out. So that's something that we're going to see. Prefab. Could you build a perfect wall prefab? Yeah. I would probably stop after the sheeting and add the outboard insulation afterwards. So that would give you the time to put your window, your flashing details, and all the stuff. And then you would add the outboard insulation on site. Could it be done? Absolutely. So you could also do the taping in the manufacturer, which is nice because you're not dealing with the environment, but you could do it also on the job site. Let's say would and the tape could go down to minus 18. So it's not an issue. So we're seeing a lot more. Let's say I know Mark, he knows that it's probably a future of the business. So offsite construction, it's something that we're going to have to deal with. So like I said, there's a lot. I'm not saying that we're going to see that in the future, but it's probably a new way of thinking and just realizing that these things could be done. And let's say a lot of people talk about the dew point, but let's say we're still building the same way, so we don't really manage those except when we deal with, let's say, vapor open, vapor retarder and stuff and those things. But let's say there's all kind of details that could be added to. Let's say in conclusion, let's say zip is probably one of the easiest system to get the building watertight, airtight without really changing any habits. So let's say we spend time with the guys on the job site. We don't have to spend that much time. Let's say we're seeing Connor over here showing the guys how to do a blower door test. I'm showing a result from Jeremiah from Summer Brothers. I don't know if Jeremiah is online today, but let's say it was their first time using zip. They did 0.32. I know, Justin, you kind of got the same kind of result when you did your first one. Um, I'd say that's pretty tight when you look at it. So we're really proud of those things. But let's say air tightness, every detail matter. So flashing will help you for sure, for sure. So you could follow us on social media for Uberwood. We also have YouTube page, even for per product too, so which is kind of cool. And let's say if there's any question afterwards, I see that the chat there was a couple of things running in the chat, but I didn't look at them. But let's say if there's anything, I could probably pull back and look at a couple of slides with you guys.
Thank you very much, Robert. This is amazing. And it's funny enough that you brought up prefab because I was up in northern New Brunswick the other week with a friend of ours, Steve Holland, and he's doing some prefab. He's doing some panelized construction
Yeah,
with Zip this year, and we're pretty sure we saw his panels in a yard. So it's happening. People are using Zip in the panelization process. And even though panelization's been around for a long time, I think the drive or the demand we have for housing right now is probably going to drive that forward faster.
agree.
Um, I know Brett Tracy had a question for you. Brett, do you want to hop on here for a second and ask Robert your questions? Are you still here, Brett? There we go.
Oh,
Let's say I
can
think
you
the
hear?
question was about the cost.
Yeah, I was wondering if you had, I don't know if you can hear me, I'm just on my phone here, but if you had any costing data to kind of compare, because that's always, the biggest thing when we're trying to
Yeah.
get people to switch to other assembly types is, cost is the cost of building. So curious if you had any information on, like an archetype house of,
Yeah.
let's say,
Let's say
2,500 square feet.
the cool part is the project was, let's say they were comparing both and they came up even at the end. Okay. But you have to remember they were building with 2x4. They were building without any cavity insulation. So you're saving cost. Also didn't have any vapor retarder. So saving extra cost. Also, let's say Zip, which has the integrated WRB, the continuous insulation, the wall sheathing. So that's a one-step application instead of multiple steps. Let's say, and like I said, let's say most of people are not using, let's say, typical air barrier on the outside. They're managing it from the inside. So when you think about all the details that you have to manage on the inside, and I'm not saying that you don't need to tape a vapor retarder on the inside. It could act as your secondary air barrier. But let's say there's a lot more details to manage on the inside than there is on the outside. Let's say just think about all the electrical outlet on the perimeter of the building. Let's say we all have three iPhones, two iPads, and let's say we need plugs all over the place. So there's a lot more details to fix on those. Let's say when you think about mechanical, let's say they're going in and out, so the amount will be exactly the same. Electrical outlet on the outside, one in the front, one in the back, maybe one on the side if you have a garage. But at the end, they were even because they were building with 2x4, no cavity insulation, and all those things. So could it be done at a cheaper way? Let's say my guess when you want to be in high performance, let's say it's going to cost a little bit more, but you're going to be saving down the line because the energy cost will just go up and up and up. So that's something that we're going to see.
Yeah, absolutely. Yeah, I mean, if you can get that much performance for minimal cost, then why not, right?
Yeah. Yeah. Let's say I'll just give you another case study. And let's say we didn't really talk about it because let's say people would say, yeah, you probably have bias because of it because it's your own house. I did the remodeling of my house during the pandemic. And let's say uh, the, the cool thing about it is my window package, there was a mistake with the window package. So I had to leave the zip exposed for 14 months. So I have a full year just on zip R in this case. Um, and that thing saved me $1,300 a year. And if I would go back at the construction, at the beginning of construction, it would have cost me less than 4,000. So in less than 3 years, I would get my money back. So, and then we did put the windows in later, and so with the triple pane windows that were passive house level, let's say we're saving 50% on energy. So it's something, and I'm in Quebec. Let's say I'm paying not even 8 cents a kilowatt. I'm not sure anybody's paying that amount. So, and we're still saving. So.
I just
Is
want to
that
jump in
something?
here. Sorry.
Oh,
No, go ahead, Brett.
No, I was just curious if that was like a case study, if you guys had like something physical that you could kind of show like cost comparisons, because that, it's always great to be able to just like show kind of hard figures of like, yeah, here's,
I can look with the Builder Association to see if they have the full case study. I know they had something published online in French, but now let's say with iPads and stuff, you could translate those things pretty easily. But I don't think there was anything about the cost. But at the end, let's say the person from the Builder Association told me it was even.
yeah.
So
Okay,
which
cool.
was cool.
Thanks,
Was
appreciate
cool.
it.
Thanks,
Yeah.
Brett.
Yeah, I just throw in there, just picking up what Robert said for Brett's question is when we look at, in this case, using service cavities because of this perfect wall scenario, we start to get focused really on the increased cost of the physical sheathing product, in this case at bar 12. When you pull back again as a GC, when you're managing then the successive trades for vapor control and electrical, not all of us are really that good at tracking our time to manage all those people to get those results. And I'll look at the example of person doing vapor control. So in my in my area, sometimes that's the drywaller. They're subcontracted to do bad insulation and 6 mil poly. We can leave alone how they're detailing it, but that's still a cost. When we have the electrician, again, detailing that for air control or vapor control, they have to include either an airtight box that we've asked them to do, so they've charged a higher line item per piece, so per point, or they've done a vapor box, which again, they charge you for. And I bet you, Brett, might well be fun. What we do is do a postmortem on your last project and look at it critically and go, okay, if I changed out these 3 or 4 pieces, what down the line could I pull out? So can I look at my electrician and say, okay, what's my base box on standard receptacle single gang versus what I asked you before? I now don't have to manage the air control or vapor control installation. I don't have to ask this person. I don't have to meet this person for ceiling penetrations. There's a bunch of knock-on effect that never comes through in these studies. So it might be fun to do postmortem your own job with that lens. Like look down the line and look at the cumulative effect. And I bet you, as Robert said, it comes out as a wash.
Yeah. And to your point, Connor, let's say there's so many people involved with, let's say, mechanicals and all the stuff. Let's say pre-con construction site meetings are important. And when I do those, I like to have trades in. When we do mock-ups, let's say it's always the same thing when you deal with mechanicals and all these details. First guy thinks that he's done it right. The second guy thinks the first guy did it. Third guy thinks the first two did it, and no one does take care of these things. But when we deal with air barrier, let's say every detail matters. So
I'm going to pipe in one more time, then I promise I'll be quiet. We often look at cost, right? What's the cost of things? And passive house and in pretty good house, we start talking about durability, right? Durability, comfort. These are things that people value, and it's hard to put a dollar on. And I think to go back to the service cabinet idea, back to the Brett, like how would I sell this? We just built a project for a client, actually built one for herself. First time did a 3.5 inch service cavity in the bathrooms and kitchens. That allowed us to put exterior wall mount faucets, which we've never been able to do for a client because, well, you can't with having the valve freeze on you. So that was huge. You can have, center window, 2 flanking mirrors, outside wall vanity with wall mounted faucets. These are all knock-on effects that don't come out in the cash, but maybe that makes the client happy. Maybe that makes the designer happy. Like, oh, cool, Brett does this cool thing that allows us to, achieve this design look, right? That they can do in California without freezing their pipes. So like, I'd be curious, like, yeah, take a look at your own projects to find those other points of selling, because sometimes that's enough to sell a client.
Yeah, that's a great point. Yeah, because lots of times, you make I don't know what the word is, concessions, I guess, for where you need to place
100%.
walls.
Yeah, like look at
when I think about not paper bear and interior side, then everything's outboard. Like just getting inspectors on board too can be challenging sometimes. They help them to inspect and they don't like what they see, or it's just new to them.
That's right.
More education on that side too.
Think like I bet you nine out of 10 of your stoves are on the outside walls, and half of our clients put in pot fillers because who can walk to the sink. This now allows you to put that in with confidence, right? Without having to like 2 pound around or something else. So, it's all little wins. So I kind of look at that stuff too.
Yeah,
There's
when Aaron and I had the discussion, let's say, Robert, what will you present? I wanted to present that because let's say with a case study, it's always fun. But let's say there's a formula that is out there. I think it's coming from John Straub to calculate, let's say, the dew point in the wall cavity and the temperature for the interior surface of the sheeting. Um, and let's say I brought that up also, and Sean is not there, but let's say back in 2017, I think Vancouver, as an example, had was asking for R22 effective R value wall assemblies, and many builders went to 2x8 instead of doing outboard insulation. And let's say in Vancouver, it's not bad because the average temperature in the winter is probably maybe 3 to 5 degrees, so it's not too bad. But let's say for sure they were creating more of a dew point because of that situation instead of doing 2x6 and adding outboard insulation. So it's something, and let's say we're still seeing some multifamily project that are done with 2x8, but I think the future will be pretty much outboard insulation all over the place, and let's say or double stud walls and all kind of situation to prevent those things. So
We've been using cavities on our ceilings for years. I'll be the first to admit, to get a service cavity on an exterior wall, it's a bit of a push for a client. There's this misnomer that they're going to lose all this space in their house. I mean, is it going to add up to a few square foot off the entire project? Yes, but it's well designed and well thought out. It's not really going to affect them. But as for the other stuff that goes along with, an airtight, well insulated house, once you build one, you you have the ability to bring your prospective client to that house and show them what it feels like to stand inside an airtight, well insulated building, the feeling you get, the comfort walking from room to room, how quiet it is. And after that, they just kind of sell themselves, really. They really do.
but let's say I did. Let's like I said, we did 6 perfect wall projects so far. There's 2 on the go, but the one that we did with an architect in Northern Quebec, and it was for her own house. Let's say when I sat down with her, she said, "Okay, how can you calculate the dew point and all the stuff?" And she was asking me at -40, -30. I said, "Okay, first of all, normally we do that calculation with average temperature because dew point goes up and down, and let's say it's not going to be 20 days in a row at -20. It's not going to happen. I'm 47 and never seen that, but I did that calculation at -40." And I think just the interior surface of the wall was still at 12 or 13 degrees. So for sure, there's not going to be any issue with condensation. And let's say they were so happy about their building when I visited them. It was fun. Young couple, nice stuff. But let's say it's always fun when you work on something at the beginning of the process and you see it in live. It's pretty amazing. And what I'm seeing from you guys when you're building stuff and you're posting it on social media, hats off to you guys.
Yeah.
Always fun.
That's a great feature from that wall assembly is it's very easy to climate tune. You
Yeah.
could, obviously you had to use R12 there, but depending on the climate zone, you could go R9, R6, depending where you're at, and still achieve that same value. So
Yeah.
that's very cool.
And you could do just outboard insulation with, let's say, EPS, wood fiber.
Yep.
It doesn't matter. There's not really any type of application. You could do pretty much what you want. So,
Well, hopefully I'll get to do a perfect wall a little later this year. We'll see what happens, but I got my fingers crossed.
I'll be there.
I'm not sure if we have any other questions.
I have a question. I have a question
Oh,
for you,
you
Rob.
said you were going to be quiet though.
I'm pretty good at filling silence. When my students don't speak, I have to fill the room. I noticed in one of your slides, you had the mock-up of the window on the right-hand side. You had the left-hand side was an installed window. If you looked up at the top of your wall, it must be the transition between your exterior air control, water control to the interior. I saw a little stitch of wiggle up across the top of that wall. Can you speak a bit about how builders like ourselves can work with different product lines? Often when we meet manufacturers, we get indoctrinated into like the system, and we're seeing it in some of your own stuff here today. I don't focus too hard on this. You're showing a mixture of different products. I
Are
think
you
that's
still seeing the slide?
nope.
No, just have
No,
you right now.
I'm just gonna I'm just gonna put it up.
So I think I know why it's there, but I'm just wondering if you can help, those that are less familiar with your product line.
You see it now?
Yeah,
Okay.
right at the top.
So when you do an airbagger, you need to have a continuous application. Okay. Um, when I was talking about air barrier on the inside, let's say normally they're going to connect the vapor retarder from the attic down to the wall, and then
Yeah.
some region will have let's say house wrap or poly going around the perimeter of the rim board and coming back every floor. Okay, or some other region will say just put spray foam in the rim board, and that's going to be fine. It's going to create a continuous application. When you do it on the outside, let's say you start from the foundation going up. Let's say I like to put, let's say, seal gasket, seal it with, let's say, Sashko stuff, and let's say, and have two bead that will be run side, not side by side, but one on the bottom and one on the top, or sometime two on each side, just to
Hmm.
have a really good air tightness at the seal gasket.
Yeah.
But when you get to the top plate, let's say you need to go connect with your vapor retarder to have a continuous. So it's like closing a Christmas box from the top. And then you're going to seal from the top with the vapor retarder. So that's a transition membrane that is put in. Do you have to cover the full top plate? No, because wood will be tight unless you put a hole in it. Okay, you could seal it afterwards with fire rated spray foam and all the stuff. But that transition will get back to connect with your vapor retarder from the attic to have a continuous insulation. So it's going to be pretty much done on the outside, but connected to the attic vapor retarder.
The floppy bits.
Let's say I
Sean and
think
I call
I
them.
think on your last one, Aaron, you were using another Sega product
Yeah.
to do that. Let's say,
I use a lot of Myrex to make that
hmm,
connection. Sometimes I'll use MyVest,
yeah,
but that's typically because it's what I'm transitioning to. I'm transitioning from zip on the exterior to Myrex on the underside of my ceiling.
yeah.
But
Cool.
I've used 3M before to do that. It just depends.
Just gonna see if I could.
We tried a detail on a client's project just last year where they had the firmer take strips of leftover zip and ripped 7-inch strips, and they ran that on top of the top plates and then folded 4-inch flash or zip tape up and over the outside edge.
Yeah,
And then for the transition from that, basically you're wrapping the WB up and over the top of that wall. We then used a 4-inch, well, sorry, this is 475. So this is a 4-inch Tescon Vanna with a split release. So 2-inch stuck to the zip, and that left that 2-inch extension that they could tape into the ceiling plane.
are you seeing it over here?
Yes.
Yeah, that's it.
So I did use a liquid flash on the foundation in this case. Some people will use let's say Fentrin Gray, which is a really good product too, or other liquid membrane too are great. You see the outboard insulation. This one was done with R9. I had some R9, so it works. And then when I get to the double top plate, I didn't put a double top plate because it was really just a mock-up, and I did tape over top plate. I don't know if I could move to the next one. So over here you see the liquid flash. Are you still seeing it?
Yep.
Okay,
Yep.
perfect. And the next one, let's say I did put Sashko
Nice.
underneath the seal gasket. So, and then you see over the top plate, you don't really have to cover the full top plate. If you do, let's say sometimes people don't like tape over there because it could be slippery if they're walking, putting the roof truss. But
Yeah.
let's say there's different ways of doing things. So, and on the inside, let's say you have the drywall, and I did put a smart vapor barrier. I did put acoustical sealant here,
Mhm.
but there's no vapor retarder for the rest of it. Just for the attic continuous application.
That's great. Really nice.
Great details.
I
Well,
think Tim has a question.
okay.
Thank you. Hi, everybody. First time caller, long time listener. Great presentation. Thank you very much for that. I'm based out here in BC, and we have recently gone through the building code change that you kind of spoke of with the 2025 NBC. It's been early adopted here in this province. And I'm just curious about the two standards that you referenced. If you could just elaborate a little bit more on how the product is being used in sort of high seismic and high wind areas.
In your case, let's say I would not recommend the zip R sheeting. I would recommend the regular zip and put outboard insulation. Let's say with the kind of seismic situation that you're getting in BC, it's way different.
Okay.
Let's say unless you have let's say another bracing method, let's say zip R will be limited to how much bracing it's going to give. But let's say the West Coast is and Vancouver Island is the same. I would recommend the regular zip, but I'm seeing a lot of people doing the zip R too. Why? Because let's say on retrofit, some will leave the sheeting there and they're just gonna put the zip R on top, or some
Hmm.
will put OSB and plywood and then put the zip R on top. So the
Right.
zip R is only acting as a continuous air barrier plus the continuous insulation. But
Hmm.
what they like about the zip R is you keep your solid substrate on the outside, so it's a little bit easier to put window, strapping, siding, and all the stuff. So there's different ways of doing things. We also see people doing, let's say, the Simpson strong tie system too, that will tie up corners and stuff. Let's say there's different ways of doing things. So
Great. Thanks.
thanks, Tim. Lori was asking if with Zipar about on retrofit. Uh, let's say when you look at the Zipar on retrofit, let's say we're seeing it pretty often. I was on a couple of job sites lately. Let's say it could be done. One thing I'm going to say is for sure if you're doing, let's say, a retrofit on Zip, and you don't have any, let's say, heat recovery or ventilator and stuff, let's say the building could get really tight. So that's something that you need to think about too, because let's say air exchanger will be critical when you get to really tight buildings. But let's say could it be done? Yes. There's all kind of things. The fun part about let's say the Zipar, what kind of insulation could you put on the inside? It could be fiberglass, could be mineral, could be spray foam. If you're using the regular zip, you could do the same thing, but on the outside, what could you put? Pretty much everything. So you're not limited with our product. So I think Leo has a question too.
Leo has a question. Come on in, Leo.
Hi guys, can you hear me?
We
Yes.
can.
Um, what does I guess where and what do you know of like maybe competitors? Um, what does the industry do in terms of durability testing or accelerated aging, sort of age testing? So, if we tear about a historic home nowadays, we find the board sheathing, and that's, plus 100 years old. I realize it never was meant to be airtight back then, but whenever I touch anything, my objective is that, if I could make it last another 100 years, that would be my goal. And yeah, what is being done? How far can one look into the future? We're gluing and taping more and more that rather than I guess mechanically fasting things, and that's always a concern for the longevity in
Yeah,
my eyes. But
we all have to go through accelerated testing to see how it would perform. But let's say I'll give you an example on tape. Let's say we have some places, let's say even in Texas, that the tape has been exposed for almost 15 years, and nothing had happened. And the same thing with the panel. So if I remember well, even at the Waterloo University in Canada, it's still the same panel and same tape since 2007. So and they went through accelerated testing too. But every manufacturer have to do that, because let's say no one will give a 30-year warranty on something without testing it to that level. So
for sure, I assumed there was something. I just didn't know what.
yeah,
So thank you for answering it.
no problem.
Yeah, it's good to know.
And some people are asking, let's say, with Zip, was it made for cold climate? Was it made for Canada, as an example? Was it made for different region? Let's say, when the family decided to step in that process, they had a committee of 6 people, and 3 of them were Canadian. So 2 of them that are well known, but even the third one is well known too. Joe Stibreck and John Straub, PhD in building science, and the third one is Chris Schumacher. Let's say John's associate with RDH in Toronto. So there's some pretty good Maple Leaf fan there.
I can also
Awesome.
say
Thank you.
I've had some projects where zip is exposed longer than it's supposed to be because, in typical carpenter fashion, it has taken me much longer to side my own house than, was ever intended. And it's covered now, but Robert saw it, when I was getting around to doing my siding and,
You were
for the
focused on your
panels.
customer, not on your house.
And I'm still focused on my customers, not my own house. But
Yeah. But let's say, just to a point, let's say I was saying about my project, let's say it was
yeah,
exposed for 14 months. After 14 months, how much repair did I do? I did replace 3 furring strip.
yeah.
There you go. So,
Aaron, so I just thought something for you. My dad always joked, who's a builder. Our basement was always unfinished, and people expected us to have like this fancy renovated house, and he'd say, Connor, the Culver's kids has the worst shoes, right?
Yep.
I think for us, the new one is the Carpenter's WRB sees the most UV, you know? I think
100%.
that's true.
100%.
Like it.
I think that
So the beautiful thing about Zip is after, it was installed, I never once had to go back and fix it after a windstorm. It's always stayed right there.
And you could get a lot of wind from there.
That is a fact. That is a fact.
Yeah. I missed the boat twice.
Oh, that is very true. It's very true. But yes, I'm actually going to write that down, Connor. The Carpenter's WRB gets the most UV.
sees the most UV. Yeah.
Yeah,
Yeah. We'll put that on a bumper sticker for you.
absolutely. Absolutely. I think I'm gonna order some right now. Unless anybody else has any questions, it is the top of the hour, and I'd like to thank Robert for joining us and sharing that case study because I think we need more of that. I think we need more, real world examples that have been documented, and we've got some data on it to back it up. It's not, a dreamed up idea. Somebody has documented it, collected the data, and proven that it works. So looking forward to seeing more case studies.
Thanks, Aaron.
Yeah, Robert, thank you.
My pleasure. Thank you, everyone.
All right. Enjoy, everybody. Thank you for joining us. We'll see you
Peace.
again next month.
Enjoy the long weekend.
Have a good evening, everyone.
Oh, and
Thanks
if you're
for
still with
organizing.
us and you're in the Vancouver area, May 21st, come visit me, come visit Robert. Oh, Robert's over there. And we're going to have a one-day building science symposium.
Yeah, 7 days out. You can find information on BS&BEERcanada.ca. There's a link to the Vancouver Symposium. Tickets are still available right now. If you are a student or an educator, there's a special discounted rate. It's $74. It's a great day. So great speakers. That includes all your food, drinks, etc., and parking. So if you're in the BC area, it's definitely should be on your list.
All right.
Okay, bye guys.
Thank you very much, gentlemen.
Thanks, everyone.